All right, so here we're going to translate and solve. I'm going to give you a bunch of words, and then you have to write an equation and solve it. Now I'm going to read them real quick. 2 times the sum of a number and 3 is 17. This one says the sum of 2 times the number and 3 is negative 11. Now, when you read them quick, you might think to yourself that they say exactly the same thing, but they don't. Now, the bottom one says the sum of. Now, so obviously sum means plus. The sum of what? Well, the sum of 2 times the number and 3. So I need the sum of 2 times the number. Well, how do you write 2 times the number? Well, 2 times the number. You can just write 2x, right? You don't need to put there. And 3. So this is what the bottom one is. It's the sum of these two things. It's the sum of 2x, and it's the sum of that with 3. And is, when you see is, think is equal to negative 11. And then I'll solve this really quick just to get the answer. Subtract 3 from both sides. You get negative 14. Divide by 2. I'm doing this part fast because we already did this to death. So the important thing is we got 2x plus 3 equals negative 11. Now I want to see how that's different from this one. This says 2 times the sum of a number and 3. So all of a sudden my computer did some weird shit. Okay. 2 times the sum of a number and 3. So this time I'm going to start here. I'm going to ignore that. I want the sum of a number and 3. Well, that's x plus 3. Is 17, right? Is equal to 17. So it is 17. But now I need 2 times this sum. So if I put the 2 here, the 2 is only multiplying the x. I want to do 2 times the entire sum. This is the sum, right? Like if x was 5, the sum would be 8. If x was 10, the sum would be 13. I want to double my entire sum, so I have to put the 2 out here. So notice these are not the same thing. These are very, very different. Up here, you have to distribute, and you're going to get 2x plus 6, right? 2 times x, and then 2 times 3 equals 17. And then you would solve it. This answer comes out total bullshit, right? You subtract 6 here, you get 11. 11 divided by 2, that's not good. I didn't make this one to solve it like the bottom one. I'm showing you the difference between the two. They're not the same. Here, it says the sum of 2 times, blah, blah, blah. And here it says 2 times the sum. So depending on where this word is, where 2 times these words are, you get completely different equations, okay? So you have to be super careful when you read these, how you write them down, even though they look really similar. The sum of 2 times, and this one says 2 times the sum. They're not the same when you actually write them down and go to solve them. Here we go. The third example, you have 7 less than 3 times a number is equal to 5 more than the same number. And you're just like, what? Okay, so most people, when they do this, they write this literally. They go 7 less than 3 times a number. And the problem is that if you try to do it like that, you're going to get it backwards, which is exactly what I did. I didn't do this correct. Like if I told you to do 7 less than 10, and you wrote this down, this is not 7 less than 10. 7 less than 10 means you start with 10 and you take 7 away from that and you get 3. 7 less than 10 is 3. It's not negative 3. So when you translate these, you have to be super careful. You don't always just go left to right and write exactly what you see. So if I want to do 7 less than 3 times the number, I have to start with 3 times the number and then take away 7 from that is equal to, okay, so 7 less than what? 3 times the number is equal to, now I need 5 more than the same number. And again, you might just, mindlessly start writing this down. And you can. It works. Addition is commutative, so you can put it, but I'm not going to do that. I want 5 more than the same number. What's the same number? The same number is x. I'm using x to represent my unknown number. Now I need 5 more than that. That means adding 5. And yes, you could write 5 plus x. In this case, these are equal, right? Because 2 plus 3 and 3 plus 2 are the same number. 2 plus 3 is 5. 3 plus 2 is 5. Addition goes both ways like that. So you can, you know, you can write this one down. It doesn't work here. You can't write 7 take away 3x. It's incorrect. So if you write this, I will not mark you wrong if you do this. This is all right. But this is the quote preferred way to do it. Now remember, I need x on the left and I need the number on the right. I'm going to write, I mean, it's going to get all ruined when I do it anyway. So I'm going to add 7 to eliminate the minus 7. And I'm going to take away x to eliminate that positive x. Remember, all about balance. Whatever you do to the left, you do to the right. Whatever you do to the right, you do to the left. You have to maintain the balance. And I like to see that you cross them out. You got to eliminate this dude from this side. I have to see this. This is your work. So you get 2x on this side. On that side, you get 12. And then you divide by 2. Remember, you don't divide by the letter. So you get 6. I mean, you could kind of check in your mind. 7 less than 3 times a number. What's 3 times 18? I mean, excuse me, what's 3 times 18? I love it. What's 3 times 6? 3 times 6 is 18, right? 3 times a number. I'm claiming the number is 6. So 3 times that is 18. And I need to do 7 less than that, which is 11. Now, 5 more than the same number. The number is 6. And I want 5 more than that. 6 plus 5 is 11. Yay, right? I mean, you could check, kind of, using the words, if it makes sense and if it works. You don't have to do this. I'm just showing you that it works, okay? So this is the third example of translate and solve. Just be careful when you do them. They're not super difficult, but they can be very, very tricky. Good. All right. A bonus question from the sheet. This is actually problem number 11 from the worksheet that we did. So it says 3 less than 5 times the number is equal to 7 times the same number increased by 11. So I need 3 less than 5 times the number. So first I'm going to do 5 times the number. And then I'm going to do 3 less than that. You've got to start with this dude and take away 3 from him. That's 3 less than this guy. 5 times the number is 5x. Is equal to, now 7 times the same number. Well, I'm calling my number x. And increased by means you're adding 2. So I'm increasing that. I'm taking 7 times the same number and I'm increasing it by 11. So I'm adding 11 to it. Now, whatever side you want to go on, if I'm doing this problem, I do this. I reverse it. Now, why am I reversing it? If I do plus 3 and then minus 7x, I'll have a negative here. I don't like having a negative in front of the x because I want to avoid the minus signs. So I will just, they're equal, right? This dude and this dude are equal, so you can switch it. So I'm going to subtract 11 to this side. I mean, I'm still going to get a negative there. And I'm going to subtract 5x from that side. Now, 7x take away 5x is a positive 2x. Negative 3 take away 11 is negative 14. I still get that negative there, but it's okay. I didn't want the negative here. So you get x equal negative 7. I could have very easily subtracted 7x to this side and had a minus 2x and a plus 14 on that side. You get the same answer. You're not going to get a different answer. All right, but I think it's easier to keep the x positive and not have to deal with the negative here. It's okay with the negative there. So there you go.